And good morning, everybody. Here are your notes for section 2.2, graphing sine and cosine. And this is going to have all four different transformations. We're going to have an amplitude, a period change, a phase shift, and a vertical shift to deal with on some of these problems. And here's the first part of the notes that want us to make two cycles of y equals sine of 2x. So notice we have a number being multiplied against the angle x, so it's going to make the angle twice as big, so it's going to rotate around the circle twice as fast, so this is going to result in a change in the period of the graph. So we know the normal length of a period is 2 pi, so your period is going to be 2 pi, but in this case we're going to divide it by the b value, which is 2. So our new period length is going to be pi long. So this is going to help us set up our scale. So let's go ahead and set up our scale. And let's go 8 boxes. So that's going to be one cycle length, but we're not going to call that 2 pi anymore. We're going to call that just a length of pi, which means 4 boxes is going to be half of that, pi over 2. And half of a half is a fourth, so this would be 1/4. So every 2 boxes is 1/4, so 1/4, 2/4. This one here would be 3/4. And then we can go ahead and put in our sine wave. So let's do the vertical scale. We'll say 2 boxes is 1. And we'll put in our sine wave. And that will be our sine wave, but the new period is going to be pi. So from here to here, one cycle length is going to be pi. They did technically say do 2 cycles, so let's graph a second cycle. So let's do a second cycle. Let's go backwards. 1, 2, 3, 4, 5, 6, 7, 8. And we'll continue the pattern of our sine wave. And this would actually be stopping at negative pi since we went backwards. So there's our sine wave with another cycle of pi. So the length of one cycle is called the period. And here's just something that we want to kind of commit to memory. To find the period of a sine or cosine function, if you have a b value, your period is always going to be the original 2 pi divided by the b value. So to find your period, it's going to be 2 pi divided by b. This part of the notes is just giving you the complete form for a general sine wave or a general cosine wave with all 4 different letters. So remember, A is going to affect your amplitude. Remember, the amplitude is always the absolute value of A, since amplitude is always positive. If you have a negative A, it's going to flip the graph upside down, but the graph is still going to have that same amplitude. Your B value is going to change the period. So your period will be 2 pi divided by the b value. Your c value is going to be your phase shift. And remember, phase shift is going left or right. And your d value is your vertical shift. So your vertical shift is your D value, and that's going to be shifting the graph up or down. And this box at the bottom, this is just giving you the steps to graph the function. You do have to do things in a certain order. Step one, you always want to do your period first. You want to do your period first, mostly because you have to set up your x-axis, your horizontal scale. So you don't want to go through graphing the whole graph and then finding that your x-axis, your horizontal scale, needs to change. So you want to set up the new period first. 8 boxes to be 1 cycle. Usually works pretty good, not all the time. So setting 8 boxes equal to 1 cycle or 1 period usually works pretty good. If it doesn't, then you can change it to 12 boxes. Once you are done setting up your scale, you then want to go ahead and graph your first fundamental cycle of sine or cosine. After you have your parent function graphed on the new scale, you can then go ahead and change the amplitude or the A value. So if it's got an amplitude change, you can do that. If it's negative, you're going to flip your graph upside down. And then the final step, you can do your shifting. Your C value would be shifting left and right, and your D value would be going up or down for your D value. And here's an example of a graph that has all 4 transformations. So notice it's going to be a value of 2, a B value of 3. We're going to have to factor the 3 off to see the true C value. And then it's going to have a vertical shift of up 1. So let's go ahead and factor off the 3. So let's rewrite our equation. It's going to be y equals 2 sine. We will factor off the 3, which means in parentheses we're going to have an x left behind, because if we distribute the 3 back in, we get 3x. Plus, and then the trick here, whatever you factor off, you're going to divide by to kind of compensate for the fact that it would be multiplied back in. So if I factor off a 3, the pi, I'm going to divide by 3. Because if I distribute the 3 back in, you get your 3x, and then you get 3 pi over 3. So the 3's cancel, and you're back to the single pi that you had originally. And then plus 1. And then we need to find our period. So our period will be 2 pi divided by the b value, which is 3. And let's go ahead and set up our horizontal scale. So let's start right in the middle, because I did say 2 cycles, so we're going to have to give ourselves room to go both forwards and backwards. And we'll try 8 boxes. And that's going to be a period length of 2 pi over 3, so we'll go 2 pi over 3, which means halfway there, 4 boxes would be pi over 3. And then halfway to pi over 3 would be pi over 6, so half of a third is a 6. So just getting a feel for our scale. And now we have our scale set up, so let's go ahead and graph our parent function. So let's start kind of small, because we're going to have a amplitude change. Or you might even be getting to the point where you can kind of jump right to the fact that it's going to be too tall. So let's maybe say 2 boxes is going to represent 2. So we know it's going to be too tall. And let's put in our first sine wave with an amplitude of 2. And we'll sketch in our sine wave. Kind of missed it a little bit there. So there's our sine wave with an amplitude of 2. So we have taken care of the amplitude. We have taken care of the period change. Now we just need to do the shifting, so we're going to have a C value, or a phase shift of pi over 3, and a D value of +1. So remember, the general form is always x minus c, so if you see a plus sign here, then it's going to be going backwards to the left, because your c is technically negative to get the negative negative to make the plus. So we're going to have to go back pi over 3, and if we look at our scale, pi over 3 is essentially 4 boxes on our horizontal scale. So we're going to have to go back 4 boxes. So we're going to go to the left 4 boxes, which according to our scale is pi over 3. And we're going to have to go up. How many boxes? We got to go 1 unit up. According to our scale, 1 box is 1 unit. So we're going to go up 1 box. So let's shift all of our points. And actually, before we shift, they did say do 2 cycles. Let's get that second cycle in there first. Alright, so there's our second cycle, and let's go ahead and shift everything. So all these points are going to have to go 4 boxes to the left and one box up. And just to save a little bit of time on the video, I just went ahead and shifted all of my black points 4 boxes to the left and 1 box up. So the final points are the green points, and that should be 2 cycles of your sine wave with those 4 different transformations. We had a amplitude change, a period change, we had a phase shift, and we had a vertical shift. And here's another example. This one's going to be a cosine wave. Notice we have a negative a value, so it's going to be cosine reflected upside down. We do have to factor off the b value, so let's go ahead and do that. So let's rewrite it. Y equals -3 cosine. We'll factor off our 2 to get our x minus c statement. So it's going to be x minus whatever we factor off. We're going to need to divide by to compensate for that. So if the 2 goes back in, you get your 2x, and 2 pi over 2, which is right back to the original pi that we had, and then -1 for the d value. So the new period, your period is going to be 2 pi divided by the b value, which is 2, so your period will be pi. And they just want 1 cycle on this one, so let's go ahead and set up our scale. And we'll try 8 boxes. And we're going to call 8 boxes pi. And we'll start kind of small because we're going to make this graph pretty big. It's going to be 3 tall, so we'll just have 1 box be a unit of 1 on the vertical scale. And then before you go too far, you probably want to check and make sure that your phase shift can be found on your horizontal scale. Usually if 8 boxes doesn't work, it's going to be because your phase shift doesn't match up with your x scale. So if we look at our phase shift is pi over 2. So if we're looking at the phase shift of pi over 2, can we find a horizontal value of pi over 2 on our x scale? So if this is pi, 4 boxes is going to be pi over 2. So 4 boxes is going to be pi over 2. So on this particular scale, every 4th box is pi over 2. So we should be able to adjust it horizontally. So 8 boxes should be fine for this one. So let's go ahead and get in the cosine curve. It's going to have a amplitude of 3. So it's going to be an amplitude of 3. So let's just plot our traditional cosine curve. We are going to have to reflect it upside down. We'll do that on a second step. Let's just get cosine plotted. So plotting our cosine points. So there's cosine with an amplitude of 3, but we do have the negative, so everything is going to get negated. So all these y values are going to get multiplied by negative. So let's do the negation of the cosine wave. I guess we'll do that in gray. I haven't used gray very much. So there's our upside down cosine wave. So that takes care of the amplitude of 3 and the negative. And we've already done the period. So we've done the a value, we've taken care of the period change on the x scale. Now we just need to do our shifting. So we're going to shift it horizontally pi over 2 to the right. So we're going to go 4 boxes to the right, pi over 2, and then we're going to go down 1 box. So we're going to go down 1. So that's going to be 1 box on our scale. So let's go ahead and shift our points. So we're going to go 4 boxes to the right and down 1. So that should be all of our new points. Oops, it's kind of a thick line. So there are your 4 new points. So that's going to be your transformation for that particular cosine wave. And the last note is just making a connection between defining a graph, a periodic function, by its frequency versus its period length. So a period is what we've been using mostly. So a period is basically how long it takes to make one cycle. So the amount of time per one cycle. And that's your period. Your frequency speaks kind of about the same thing, but in a different way. It talks about the number of cycles. So the number of cycles per 1 unit of time. So the number of cycles per 1 unit of time. So for example, let's say I had a unit of time of seconds. So let's say this was 1 second. And let's say the frequency of the graph was that it repeated itself 10 times within that 1 second. So if you can imagine, it went 1 cycle, 2 cycles, or 3, the 3rd cycle, 4th cycle, 5, 6, 7, 8, 9, 10. So in this case it went 10 cycles per 1 second. So we would call that the frequency, 10 cycles per 1 second. What would the period be? The period is how long does it take to go for 1 cycle. So just 1 cycle from here to here is basically 1/10 of a second, because it did 10 of them in 1 second. So the period is going to be 1/10 of a second per cycle. So it did 10 cycles in a second, or 1/10 of a second for one cycle. So essentially your frequency and your period are just reciprocals. So for example, if your period of a function was 2 pi over 3, then the frequency for this function would just be the reciprocal of that, 3 over 2 pi. So your frequency and your period are just reciprocals with each other.